Hello guys, we are live and I will share with you the class link. You can check the WhatsApp. Just give me a minute. I will share with you the link. Share. Just give me a minute. Okay, it's perfectly shared and let's start the class now guys. Welcome to Cheenta Statistics Analytics Department, and yeah, so we are live now and let's do this exciting set of problems that we have today. Let me introduce, yeah, Sriteja is in the class. Okay, so let's start the class. Till now what we have done, until now in our live theory classes, we have done, just give me a minute, yeah, we have done till joint distribution and we have done marginal of discrete random variables, like discrete joint random variables we have done. So now today we will be learning something interesting and we're doing something interesting problems. Let's start it. Okay, let's start and let's see what I have on my plate today. Just give me a minute. Okay, so I have discussed joint moment generating function, right? Did I define joint moment generating function, guys, last day? Did I define, guys, joint moment generating function last day? I think I had. I just defined it. As far as I remember, yeah, I did it. So maybe you forgot. It's not a very big definition, so I did it. And let's do this problem, okay? So let's see what joint moment generating function is. Okay, Ptolemy, do you remember the problem you are facing issue in? Can you share the problem with me once? Did it get clear? That joint moment generating function was a problem? Anyways, so yeah, let's do this problem together. So let's first define what is joint moment generating function. In fact, moment generating function is a problem solving idea, okay? It's a problem solving like strategy. So why are moment generating function important? Because it helps us to discover moments. Helps us to calculate moments from the function itself. Helps us to calculate moments from the function. It's from like Mgf function. So how is a multiple random variable ka moment Mgf defined? It's defined like this, that expectation, like if x1, x2, xn is the joint random variable, okay, then the moment generating function, let's call it x curl. The moment generating function of this, let's say g of x curl of t is another vector, okay? So what is t? Moment generating function is actually a multidimensional function. So g x curl of t1, t2, the Tn, exactly same number of variables as this, is defined as expectation of e to the power e to the power summation I from 1 to n ti xi. So this is the how joint Mgf is defined. Okay, why is defined like this? Let's not go into that. Let's define like this. This is a definition. It's a very easy definition, so that's why it's done as a problem-solving aspect. So this is the definition of joint motivating function. In fact, in IIT, you will not get more than 2 random variables, so it's just 2. So here, determine MT1 and MT2 is given over here, where the joint PDF is given. So let's try to calculate it. Let's try to calculate this. Okay, it's a past IIT JAM problem. So let's calculate this. So how we can calculate the joint motivating function of these 2 random variables x comma y? Okay, and perfect. Please follow me here. Can you please send me the problem if you have? I don't know if she's online or not. If you are hearing me, if you're in the class, please send me the problem of the Mgf you had issuing. Okay. Yeah. So therefore, let's see this problem. Let's look into this problem. We need to find m of t1 comma t2. So m of t1 comma t2, you need to find it, and which is therefore expectation of what, e to the power t1 x1 x plus t2 y, because x and y are 2 random variables over here. Right, this is what you have to find exactly. And how do we calculate it? How do we calculate it? Well, let's just put in the values. How it's just defined. Now x and y may not have been defined as okay. So how is this defined? So this is where I told that again the lotus is coming. What is lotus? If you remember, the lotus for one dimensional random variable, if you remember the lotus, what was lotus? It's a problem solving strategy, right? What was the lotus? The lotus is the following, that it's telling you how to calculate expectation of a function of a number of a random variable. So it's told that expectation of function of a random variable f of capital X can be done. It's called a law of the unconscious statistician. So how is this helpful? It's helpful in the sense that I will tell you how it's helpful. So let's say x has a PDF G. Okay, or let's say x is a PDF F, and we are trying to find expectation of x, G of x. We have done it in one dimensional random variable. I'm doing it again. Then how do we find it? We just find it as integration minus infinity to infinity. What do you do? Instead of x, how do you find expectation of x? You integration minus infinity to infinity, or summation. How do we do? We do it x in terms of expectation. We do x fx dx. We do this, right? So here what we do, if the statistician is unconscious, even that person will just replace x by g of x. If it was x over here, it would have done x. It was g of x, it would have done g of x. So therefore, to understand, to find the expectation of gx, we need not find the distribution of gx. Okay. So this is the basic idea. To find the expectation of gx, we need not find the distribution of the gx. So this is the hint. Like this is the star idea. And to find the expectation of gx, the random variable gx, we need not find. We are not required to find. That's a great step ahead. Like we are saving a lot of time. We're not required to find the distribution of, because we have seen how distribution finding can be really tedious, right? We have seen that. So therefore, it's a very easy step of doing this, and it's really super helpful. This theorem. So this we will extend it to multiple dimension. We'll expand this to multiple dimension. So how do we do it? So in case of this, it's very simple. If there's a function f of x1 comma x2, we find expectation of f of x1 comma x2 as integration 1 over x1, 1 over x, like let's say like whatever the region is R, f of x1 comma x2 into let's call it g of x1 comma x2 into, let's say x1 comma x2 together has a joint distribution. We understood we have a joint distribution, or summation is also here, any one of them. Joint distribution, let's say f of x1 x2 small x1 x2. So it's into the, just like the one dimensional random variable. So this is the idea. It's called a law of unconscious statistician, because just putting in the value of g of x1 comma x2 over here. So this is done. This is the idea. This is the definition. Okay. This is the basic idea. Okay. Okay. All of you understood this, guys? All of you understood this? All of you understood this result and theorem? Yeah. Perfect. So we'll use this theorem and a result to find the expectation of this. Find expectation of this. So let's do this problem. So this is how you do it, okay? You don't find the distribution of x and y, x plus t1 x plus t2y, okay? So let's calculate. We need to find, therefore it's a, let's see what type of problem it is. It's a discrete random variable problem, because I've taken this problem because we have done this problem only. You have done this till this point of time. So let's calculate this. So let me just copy and paste the region again. Baad mein. It's easier for you to understand. Okay. So therefore to find m of t1 comma t2, which is expectation of e to the power t1 x plus t2y. Now we will do the summation part. Summation. Now understand there are certain conditions. So we have to see the conditions, how x and y are behaving. So x is going from 0 to y, and y is going from 0 to infinity, right? So let's calculate over here. It's like e to the power t1 small x plus t2 small y into e to the power minus 2 x factorial into y minus x factorial, right? This is the probability of x is equal to x and y is equal to y part, and this is what? This is the g of x comma y part. So this is the basic idea. This is the basic usage of the lotus in discrete random variable. All of you got this step, guys? All of you got this step? We are doing very step by step. Yeah? Perfect. Superb. Let's now calculate this. Let's now calculate this summation. So this is where, as I told, when you are doing this problem, one thing remember is this is the problem of the tip of the day. Always this is the most important problem solving strategy, and this is the most creative part of every single exam and solving problem. Is that you need to find, you need to map. There are a lot of problem solving strategies like this. You need to find or map. So Sneha, I think Sneha recently faced a problem, right? Like Mgf wala. I hope you understood the strategy, right, Sneha? After that, she asked me in the one-on-one group. Yeah. So you need to find or map a known expression to a random expression to known expressions, and that is super important. You will not understand how important is that and how much time it saves. Why? Because you know the ideas and results about all the known famous random variables, and if you can map this sort of expressions to the known random expression, known expression, this is the most important idea. So map this expression to a known expression and use the properties of that known random variable. In fact, it is done over all the mathematical research and everything. Okay, this is the only idea. We map new knowledge to the previous knowledge. Okay, so to the properties of that. So let's try to. I don't know whether it will work over here or not, but that is for the first step I do. So therefore I will suggest you to do also. Okay, but you can find your own methodology also. But this is the first step. So let's do it. Let's try to find and map it to the known distribution. So it's e to the power minus 2 and x is from 0 to y. But maybe also here we can have to find or do it in a different way. I don't know what it is, but let's do it. Let's try it out. So let's write the expression down अच्छे से. Summation, let's write it on one small way. Summation x goes from 0 to y and y goes from 0 to infinity. It is e to the power t1 x plus t2 y into e to the power minus 2 by x factorial into y minus x factorial. Yes. So this is what you have to find. It is a function of, you can understand it's a function of, like let's say some f of t1 comma t2. It will be a function of this. So let's try to find out f of t1 comma t2. Let's find this out. And if you find this out, guys, so those people who have joined the live late, you can go back and see the problem we're discussing and then come back here to get in like the pace of the class, with the pace of the class. So good. So now comes the creative part of you guys. Tell me what you can map this to. Anything you find similarity. Let's first hold the x part. Anything you find similarity to the known expression, guys? Anything? Any ideas? Sriteja tells Poisson. Anyone else? Any other ideas? Binomial. Any other ideas? Poisson 2, binomial 1. Let's make a poll over here. How many things Poisson, how many things binomial? Known expression. Binomial, Poisson, none of the above. So I have launched it. Can you please check the poll and answer it correctly? Whatever you think. What do you think? Can you see the poll? Go to activities section and you can see the poll over there. So one people think binomial, one person think binomial, one person thinks Poisson. One person thinks none. 2 persons thinks Poisson, 1 person binomial, 3 persons Poisson, 1 binomial, 1 none. 2 binomial, 3 Poisson, 1 none. Okay, 3 binomial, 4 Poisson, 1 none. So who thinks it's none? Can you just tell me? I just want to know which distribution you think, so that I can understand what's going on in your mind. Anyone who wants to, who thinks that it's none?
So I choose none because I really don't have any idea. If it's either binomial or Poisson.
No. Just tell me what do you think it's what do you think? You have an intuition, right? Inner intuition, right? You have done so many problems till now. So even what does the intuition say? What does it match like the most? Which PDF you have to map it to what? You have to map it to the PDF. Because why PDF? Because you know that integration or summation of a PDF is 1. So you can use this idea. So you have to map it only to PDF. So which PDF ke saath you can compare, you can think it's equivalent to that. Looks like that. Which PDF ke saath you find? Because you have to know the remember the expression of the PDF. That is super important. Huh?
Binomial.
Good. So let's see whether it's a binomial or Poisson. So to me, I find it right now it's binomial, but it can be something else. So let's see. My intuition tells it's binomial. So let's understand whether it's binomial or not. Let's understand what we can do. Let's understand that. So I felt also binomial because x is going from 0 to y. So binomial it goes from some of the 0 to that portion. So in binomial we have, let's understand this. Let's take this portion. So to have this binomial, you also must have a y factorial right over. And niche we need to divide by y factorial. So let's see the x portion now. The x portion. 0 to y. So x portion is this. X factorial y minus x factorial e to the power minus 2. E to the power minus 2 is Bahar. It's a constant part. So here's x factorial part and e to the power t1x. And Bahar is, it's Bahar. E to the power t2x is Bahar. Understand to make it, so you see that this comes in n choose x only. So here and also it's over n or sort of here. So if you multiply y factorial over here and divide by y factorial outside, so it looks like maybe binomial. I don't know. Let's check it out. C to the power minus 2 e to the power t2y by y factorial into summation of x from 0 to y e to the power t1x times y choose x into what? Into nothing is there. So what will we do now? Abhi next step kya hai? So we have tried to understand in terms of binomial, right? So what do we do next?
So half to the power y.
Okay, any other ideas? So why half to the power y? Because in other cases it's p to the power x into, it will be what? P to the power x into 1 minus p to the power y minus x. But we cannot introduce this p, y, because if you introduce that, it's dependent upon x. It's not dependent upon y. If you introduce different p. Okay. So the best thing is to do is to introduce half to the power y because it's dependent upon y. So it will be, because if you put p is equal to half, a very good idea. I don't know whether it will work or not. Okay, I'm just trying it out right now in front of your eyes. So it's if you multiply it by 2, you can see this now follows, x follows what? X follows now binomial y comma half. You can sort of understand this. X given y follows this. X given y follows this. You sort of get it. Okay. So that's a good idea. So you have to multiply by 2 to the power y. So this is the idea you should think of. The only strategy is that connect it to non-random variables. This is the only way out. Okay, that's the thing they are wanting, whether you can recognize non-random variables out of this or not. That's the only thing they are looking forward to, and that's the only thing they're trying to exploit out of your mind. So this is the idea. Now what is this? Can you just tell me what is this? So let's see. I don't know whether it will follow what it follows. It can happen like that. You may be right. You're right, maybe. So that's a very good idea. I don't know. I am doing it with you only. So let's understand this. So what is this? What is this? Can you just tell me what is this?
Mgf.
Very good. It's Mgf of binomial. Superb. Binomial y comma what? Half.
Half.
Good. So let's write it down first. So we have got that f of t1 comma t2 is summation of y from 0 to infinity. We have got here e to the power minus half. We have got here y factorial. We have got here e to the power t2y. Below me into, I think you have got also other things.
So we are finding out the joint Mgf of t1, t2y.
Yeah, we are finding out that.
Okay, function of t1 remains mgf by m t1, t2.
क्या?
Means we are writing f t1, t2. Means we are writing joint PDF.
PDF. No, I have defined this as
Mgf. Okay.
Yeah, Mgf. I'm sorry for the notational error. Okay. So yeah, I defined it at that. So into this we have got one into Mgf of. It's a very good observation. We have got here Mgf of binomial y comma half. So let's write it down. So can someone tell me what is binomial? So during the exams, whether you're giving short mock test or regular weekly mock test jo hota hai, if you're giving short mock test, you can use the like the source, okay? But the idea is that you must make a cheat sheet of that, okay? And that is the thing you should do, make your own notes. I have focused on this a lot. So make your own notes. And can you just tell me what is the Mgf of binomial y comma half? So binomial के Mgf of p is p plus q, p whole to the power
Q plus P to the power n.
yes. So p plus q to the power n. So p is half, q is half, e to the power t. Here it's t1, I guess. So t2. Here it's t1. Sorry. Whole to the power y होगा, right? All of you understood it. Whole to the power y होगा. All of you understood this step, guys?
Yes, sir.
Yeah, others did understand this step. It's very important. All these problem solving strategies are important. Others, did you understand this step? Please reply. Nikhil, did you understand? Good. So now, y from 0 to infinity, let's write it down together. Now it's terms of y. So now you have to fit it another distribution. E to the power minus 2, and this half to half, this to the power half will get cancelled. E to the power t2y by y factorial into 1 plus e to the power t1 whole to the power y. So let's write it down. Next, so we have got f of t1 t2 as summation of y from 0 to infinity e to the power minus half, sorry 2 e to the power t2y good. So let's try to now map to something you know. So already Mansi gave an idea that maybe it's related towards Poisson. Okay, so let's see if it's related to a Poisson or not. So Poisson का density is what? PMF is what? Poisson का PMF is
E to the power lambda T2 minus 1.
huh? Good. So e to the power minus lambda to the power x, sorry, y होगा यहाँ पर by y factorial. You can understand it will be y only. So y factorial is already there. So you find out this lambda stuff. Okay, and you can understand 2 must be over here. So lambda to the power 2y hoga. You can understand that. So you can understand that. So let's make it a e to the power minus 2. But there can be much more because e to the power is there also. So 2, let's see what it will be. So e to the power minus 2 minus t2y ऐसे होगा into और एक part है, ठीक है. So how do you manage this part? Any ideas? How do you manage this part? Because this can also go into the aspect of like Mgf also. So how do you manage this part? Any ideas? It will minus lambda. So t2y तो यहाँ पर नहीं होगा. So if you divide it by 2 to the power y, multiply by 2 to the power y, so you get the Poisson का Poisson 2 as Mansi has told, and you divide by Poisson 2, so you get e to the power t2 y by 2 to the power y. Now how do you do this? बोलो. Okay, so now how will you tackle this part? So this is our already got point show 2. So how will you tackle the rest of the part? How will you tackle this part? Any ideas? I think I have done the calculation. Okay. So how do you tackle this part now? Any ideas? Any ideas, guys? Okay, so there are certain suggestions from the YouTube live. Is that we can compare with the Taylor series expansion of e to the power f t1 t2 without assuming Poisson. We can do that. That's a very good idea. But that's a very good idea also. That's also a very good idea. We can compare it. But the idea is that it's about understanding and doing it in a general manner so that it's easier for the students to understand the probability. So I prefer this method, but it's your method is also fine. Vivek Verma is telling if we leave the Mgf of x, then the remaining portion is Mgf of y. Wait, if the leave. Okay, how is that coming up? So that is not the Mgf of y. It's a problem. It's Mgf of y given x into Mgf of something different. X given y.
Yes, we can consider this 1 plus e to the power t1 in the bracket as lambda. And then we can adjust e to the power 1 plus e to the power t1.
Good.
And e to the power 1 away.
Good. Superb. Superb. Yes. Very good. So what Ptolemy told is the following, that we need to do it in this lambda. What we can include in this lambda, you have to check it out. Okay, that's a very good suggestion. Thank you, Ptolemy. So what she's suggesting is this, that we have this part extra. So why don't we include it in here? 1 plus e to the power t1 whole to the power y. Okay, so what extra change we have to make? We have to make change over here. 2 into 1 plus this. Right? So what we have to add extra? We have to add this extra out of this here. So वो बाहर चला जाएगा because it's not dependent on y. So it's 1 by, I'm adding, so e to the power minus 2, she's adding 2. We are adding 2, just give me a minute. 2 e to the power t1 I'm adding, I guess. Yes. Just give me a minute, I'm just checking. Yeah, I'm adding minus 2, let's check it out. E to the power minus 2 plus e to the power t1 minus 2. Yeah, I'm adding this part. Okay, so you can see that it's correspondingly added and subtracted to get this. So the rest of the part is e to the power t2y. Superb. So it's done. Very good, Ptolemy. Nice. Nice. Superb. So why doesn't follow this, but why rather follows? Why show 2 into
That the value from the denominator.
कौन सा?
To the power y.
Here, this one.
Yes.
Okay, yeah, I missed that. So let's include in this. So it's e to the half into e to the power t2y, right? Whole to the power y, right? This one, right? Yes, thank you for that. So yeah, so it's Poisson e to the power 1 plus this is the Poisson and this is the extra part. So we are getting, therefore it's equivalent to e to the power 2, yes, e to the power 2 e to the power t1 times expectation of y, where y follows this. So y actually it's not y. Sorry, this is not y. Um, but you can actually define it as something else. Like no, y actually like okay, y actually follows this. So you can define it as half into to the power. ठीक है, fine हो गया. So now you know that t2y कुछ गड़बड़ हो रहा है. Yes, whole to the power y. So let's write it in the next page. So we get f of t1 comma t2 as e to the power 2 e to the power t1 into expectation of y, so where y follows point show 2 into 1 plus e to the power t1 half ठीक है. So we can write it in terms of Mgf. So this is actually written as Mgf मतलब क्या होगा, e to the power something. So you can write it as what? This can be written as half into then written as e to the power what? Log half minus log 2 into the power 2 whole to the power y. So you can write e to the power 2 e to the power t1 expectation of y e to the power t2 minus log 2 whole to the power y. So therefore y का like पॉइंट्सों का mgf क्या होता है बोलो. So let's call it t3. So पॉइंट्सों का mgf क्या होता है? What is the mgf of point show? E to the power minus lambda 1 minus e to the power t. E to the power minus lambda 1 minus this, right? Let me just check. This, right, Satej? So therefore here it's t3. So here it's t3 is this. So t2 minus log 2. And lambda here is different. हो गया. So this is the final MGF. Also understood it? Any doubts in this way of thought?
So in the previous page, can you explain the last step?
Yeah, which one? Which part bolo?
This one, expectation of y.
So see, we understood that this is something to do with Porsche, right? We understood that. So we have to find the lambda over here. So therefore lambda is lambda to the power y. So we are collecting all the to the power y together. Okay. So this is the to the power y together, and I think there's some certain issues over here. Wait. Okay. I think there are certain issues. Yeah. So 2 to the power y is not there. Okay, so we multiply 2 to the power. In fact, yes. So this part is there, lambda to the power y. So we need to include it over here. Okay, but before that, sorry, not this. I'm doing something wrong, I guess. Just
Means if we take e to the power minus 2 outside of the summation, then it's something like Mgf of Poisson, means e to the power t2y is there. So
just give me a minute. This lambda to the power y, we can also take this as lambda also. So we can also do it like this. So
we don't need 2 to the power y.
No,
Yes, we don't need 2 to the power y.
we need something actually. We need something different. So we need to do it as e to the power minus lambda, lambda to the power y by y factorial. Okay. The good thing is that here you can sort of write it as lambda to the power y. This lambda can be written as this e to the power t2 into 1 plus e to the power this into this. This is the lambda part. Okay. This part is the lambda part. So you can write it as this. You can write it together like this. So this is a lambda now. So to make this lambda, we have to make some changes over here, right? So to make this lambda minus lambda, we have to make some changes over here. So it can be done in a very easier way actually. So let me do it in a different way. A little bit longer. Yes, you're right. So we will do it this way. This is the f of t. This was the f of t1 comma t2. That it's summation y e to the power minus 2 e to the power t2 into this 1 plus e to the power t1 whole to the power y, right, by y factorial. So you can understand it's lambda to the power y by y factorial. So lambda you have to change, which is not dependent upon y. So you have to multiply that lambda here. Okay. So what is that extra lambda? So therefore this is multiplied. So let's call this lambda. And let's here we have to make it lambda. So there was minus 2. Okay. So we take it outside, so e to the power minus 2 in plus lambda. This is the case, right? So this is the extra part we need to do, right? And therefore this sum is 1. So this is turning out to be e to the power lambda minus 2, which is coming out to be e to the power t2 into 1 plus e to the power t1 minus 2. This is coming out, and let's check. I think it's matching with this. Yeah, I think it's matching with this. You can just check it out and you will see it's matching with this actually. It will be matching with this. Yeah, I have done a bit more work. It's same thing. Did you understand this one, guys? Did you understand this one? Yeah, you're right, Mansi. I also understood this one. Satyaj, we are actually done. So actually this is the same thing. If you do the calculation after the class, that this we expanded. So if we expand it, you will get e to the power 2 t1 into e to the power minus e to the power e into minus e to the power minus like e to the power minus 2 e to the power t1 into 1 minus here. So if you do this calculation, you will see that you will get exactly this thing, the previous one. I believe so. Okay. And okay, perfect. So this is a much more easier example, and Satyaj's idea that why we are not using that. In fact, the idea that we are using is like e to the power y is equal to summation e to the power y by y factorial. That is equivalent to the idea that Poisson PMF sum is 1. If you see that, Satyaj. This what you have told the Taylor series of e to the power y expanding, that is equivalent to the Poisson PMF is 1. So we are doing the same thing. Both are not coming out to be same, then I have done some calculation mistake over here. So this is the correct one.
So that you have put e to the power minus lambda, it's the same that is within the bracket before y.
I didn't get you this one.
So e to the power t2 into 1 plus e to the power t1 bracket में.
Yeah.
This is lambda, right?
This is the lambda, yeah.
So before the bracket where we are written e to the power minus lambda. Where lambda is the same expression which is in the bracket.
Yeah.
So the term which you have written after the bracket, whole bracket,
Yeah.
is it the same?
So we have lambda, which is cancelling out here, and we have extra e to the power -2, so which is here.
Okay, yes, got it.
Okay, all of you understood this? Yeah, it was a very good problem. Okay, good, nice, superb. So these are the things that you need to study. Polomi, will I discuss that problem?
Okay, means now I went back to the problem. It says that find the Mgf of Z equals x plus y. Then we have to
Wait.
find
I will just do the
some
problem.
unique.
Just give me a minute. Problem is asking x is x1 comma x2, 2 cross 1 random vector with joint moment generating function. This find the.
My question was not this one.
Oh, okay.
Okay, the hand become one.
Sorry, my bad. We will do this also, okay? So question you're asking that m of t1 comma t2 is this. Let me write it down. Okay, this is a bit of a difficult. Do you have the? I think it was a past. Give me a moment. I think I can find out. Just give me a moment. I think it's actually a past year IIT problem only. Anyways, the previous problem was really good. I like the idea. So the main idea theme of the problem is connect it to known random variables. Okay, that is the smoothest way of doing it. I'm not finding the problem. Let me write from this problem only. It's given that m of t1, the moment generating function of two random variables like x1 comma x2 is 1 minus 1 t1 plus t2 into 1 minus t2, where t1 is any real number and minus infinity is less than t2 less than minimum of 1 comma 1 minus t1. Then x is equal to z plus x plus y. Okay, so let me write it down properly. This is a bit more involved.
Since I have got the question, means I have got the question, picture of the question.
Oh, তুই এতক্ষণ শেয়ার করিসনি কেন? যাক আর বলে লাভ নেই, আমার লেখা হয়ে গেছে।
Just now আমি ভিডিও থেকে স্ক্রিনশট নিলাম।
Okay, ठीक है। So z equal to x plus y. So this is the, we have to find the variance of z, okay? And good. So we have to find the variance of z, but before that, let's understand this m t1 comma t2. This weird condition is here that t1 is less than minimum of this comma this. Okay, so the t2 is actually dependent upon t1. It can happen, actually, it can happen. But this is, let's find out z of Z is equal to x plus y. You have to find the variance of Z. So as you know, if you find a moment changing function of Z, this will be done to find Mgf of Z of t, which is equivalent to expectation of e to the power t z. Z is what? Expectation of e to the power t x plus ty. Now understand what is this Mgf? This is what? This is expectation of e to the power t1x plus t2y. So therefore we have to find this. We know this result is general result. So if we put t1 is equal to t2 is equal to t over here, we can find the Mgf of this from this. We know the expression of this. So therefore this is turning out to be what? If we put t over here, it's turning out to be mt is what? mt comma t. It's same as mt comma t, which is equal to 1 minus 2t into 1 minus t, where there is a condition over here. What is the condition? Let me write it again. That mz of t is equal to 1 by 1 minus 2t into 1 minus t, the condition that t is less than infinity to minus infinity and t is less than minimum of 1 comma 1 minus t. Okay, so this is a weird condition. So how do you do that? What does it mean? It means that if 1 minus t is less than 1, t is equal to 1 minus t. If t is equal to 1, if 1 minus t is greater than 1. This is the idea. Like t is less than this. So t is less than 1 minus t. Sorry, I'm writing. This is the basic idea. Let me write it down again fresh. So what does it mean? These are the conditions which may confuse you. That t is less than what? T is less than 1 if 1 is smaller, that 1 is less than 1 minus t, and t is less than 1 minus t if 1 minus t is smaller than t. This is the case only, right? So let's see what it means. That means t is less than 1 if t is less than 2. If t is less than 1, if sorry, t is less than 0. T is less than 1 if t is less than 0. That is what it means. And here it means that t is greater than equal to 0, and here it means t is less than half. Okay. So this is a bit weird. So how do you find t? Any ideas? Any ideas how do you find this t now? So Tejka way is also good. We can find that. But there's some condition over here. This condition is usually not present. So will t follow always this? So that's my question. Because t usually less than 1.
We need to find, means we need to identify the MGF, means the distribution from the MGF, MZT, or what we have to find.
We have to find the Mgf of Z first. What is the condition on t? What is the condition on t? So do you know some Mgf which have such conditions?
Yeah, means it is similar to gamma or exponential MGF.
Gamma, exponential. Which PDF has this condition, like that t must be less than something? नीचे this होगा. So you have to find such conditions, otherwise it will not be okay, na? So you have to find such conditions that t is less than something. T is less than 1, T is less than, so let me write down the list over here. See, to find out, let's find out together. I don't even know how, what is the solution, but this is the way out. So as you and understand, the thing of solving this problem is that the two ways of doing it. Just do it normally and you can differentiate twice to find it, or the easier way, the intelligent smart way is that, or I'm teaching you the smart way, that find the relationship to a known distribution. That's the smarter way of doing it. Let's see the list of all such MGF. Satyaj, what you told will help you to find the marginal distribution. If you replace one of them by 0. Let's find out where this niche T hai. So this is not clearly, हाँ बोलो.
By visual inspection, we can say that when we put T1 or T2 is equal to 0, both of them turn to be exponential. And then we can use the additive property for Z. That's what by...
No, but they must be independent. Are they independent? Are they independent?
No, I guess.
No, right?
No, but both of them marginally are following exponential.
So
that's what we need to actually find. So
but
Z
we
is
need to
equal
have
to
the
X plus 1.
we need to find variance. So it involves a covariance also.
So we can get the distribution of Z by just using additive property of exponential.
No, that is their additive property of exponential. Don't remember these results blindly. If they're independent, they're adding up to like gamma. If they're not independent, they're not adding up to gamma. So if there's some covariance, they will not add up to gamma. You understand?
Okay, sir. Okay.
Yeah. So here, let's see. So it's like T minus something kuch hai niche. So this is not there, 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 this is not there. These can be there. This is not there, this is not there. But I can also see my screen is broken in this region. This is not exponential ka, it looks like it may be there. हाँ देखो एक्सपोनेंशियल का कंडीशन है t लेस देन लैम्डा, यू सी दैट गामा की एक कंडीशन है. ओके सो यू सी t लेस देन लैम्डा बोल के कंडीशन है, सो एक्सपोनेंशियल गामा कैन बी अ गुड चॉइस. सो लेट्स टेक दैट. All understood how I did it? It's good to remember all this. Laplace is not important, but this set of all the Laplace may not be important, but all the others may be important to remember. In fact, you have to remember that. All the others, remember that, please. It will help you a lot. So make a sheet of that, all the ideas. Okay, all of you understood this idea? So we discovered one single idea is that take a known distribution and like try to take a something new and try to map it to known distribution. But we don't know yet what it is true. Let's see that. So let's take that portion over here and let's see whether it's true or not, because I don't know what it is. As Satyaj has told that it's product of two, maybe, I don't know, maybe exponential. But you know, why didn't you tell like didn't you like, okay, let's check that. Okay, let's check that. So let's check gamma ka. So gamma ka MGF is something like this. But there is a small problem over here. The small problem is this, that as you can see over here, exponential ka is based on one single type, but there are two types. I think Satyaj's way can be a good thing over here, what Satyaj told. There's a reason to that.
So can partial fraction help? It's just an intuition.
Partial fraction can help, but partial fraction okay, just give me a minute. Just give me a minute. This is a very weird condition. Actually, it's not a very weird condition. T is less than half, T is less than 0. Okay, so from this condition you can understand that if T is less than 0, T is less than 1, which is automatically true. So T is less than 0 is a condition, and T is less than half given T is greater than or equal to 0. That means T is always less than half. So given this, it turns out that T is actually less than half. Always. You can understand it from here. Because if T is less than 0, then only T is less than 1, which is always true. And if T is greater than 0, greater than or equal to 0, then T is less than half from this condition. So T is less than half is the final condition from here we are getting. So you're getting that Mg of 2 T is coming out to be 1 minus 2t to 1 minus t into T is less than half, this condition. This is super important to understand. In fact, it's true because you can understand T is less than half hoga, because uske baad it will not be defined. It will be actually negative. Okay, and that's the idea. So T must be less than half to make it both positive. Both must be less than 0. So T is so less 1 के बाद में 1 minus T is negative and positive 1 minus T, and half के बाद में 1 minus 2t is negative and 1 minus 2t is positive. So in this region the product is positive, in this region the product is negative, in this region the product is again positive. So they are not taking this part, they are taking this part, because इसमें there is a condition, they are taking this part. Okay, T is less than half. This is a final Mgf of T Z of T. So there can be two ways of doing this afterwards. Two ways of doing this is the two ways of doing are you have to find it out what this Z is, something known or not, or you can actually find it out whether, I think Z is something not known, because gamma के लिए what happens, if you see the gamma के लिए it is actually equal to 1 minus theta t whole to the power minus k. So what will happen is that this is not of the single format, it's the two divariant format of that. So this is a bit of a trouble. Okay, this is a bit of a trouble. So how do we find it? How do we find it? So one thing what Satyaj told is the following. That's also interesting suggestion, that x1 comma x2 of t1 comma t2. So if you put 0, you get the marginal Mgf, right? Because it's expectation of e to the power t1 x1. You get that. So you get marginal of that. You get what? If you put t1 is equal to 0, you get 1 minus t2 square. If you get t2 is equal to 0, you get something else. But there is a small problem. The problem is that they have not covariance 0. So we cannot write, or maybe they are not independent. Okay, we cannot write like that. So that's a bit of a problem. So therefore we have to do it in this way only. And since they are not, their covariance is not zero, so you can understand individually there will be, individually there will be,
You cannot write like your voice is not audible.
yeah. So the idea is that we understood the marginal. If you put, okay, let me write it down. M of x1 comma x2 t1 comma t2, it's turned out to be as a, so if you do M of x1 comma x2 comma t1 comma 0, you get 1 minus t1, which is equivalent to the marginal of, when x is x1 is follows marginal exponential 1, and if you put x1 comma x2 0 comma t2, you get 1 by 1 minus t2 whole square, which is gamma, कहाँ गया, which is gamma, huh? Gamma 2 comma 1, I guess. Thing is that if you add these two, if they're independent, if you add this to x1 plus x2, you will get another gamma, because this is gamma 1 comma 1, I guess. But thing is that it cannot be written as, they are not independent, they are together. So x1 and x2 are covariance is not 0. They are independent. So you cannot write the summation, because summation of independent exponential or gamma is gamma, but not non-independent stuff. How we can understand it's not, because you cannot write it as product of these two. That's why. If you can do it, you can write it as product of x1, mgf of x1 into mgf of x2, you can write it down. But you cannot write it like that, because t1 plus t2 is over here. So we know that x1 and x2 are two exponential, but they have a covariance, they are not independent. So their summation will be something different. But it's a good thing you observed. So what to do? The next idea is that from the MGF, you have got the MGF of t, MGF of z. So from that you have to find out expectation of z and expectation of z square by doing differentiation. By doing differentiation, you have to find out. By doing 1 times differentiation, you have to find it out. And there where a Sneha or maybe, I don't know, Tishika's idea of partial fraction will help. Okay? So there where it will get help, some help. So how do you write it down?
In the Mgf of Z, we get means what we can feel is that there is a product of two Mgf. From this, we can't do anything.
It's not product of 2 MGF. That's what we cannot do it. We cannot do product of 2 MGF. That's the problem. If we can do a product of 2 MGF, we could have done something. It's not a product of 2 MGF. It's not a product of this. Did you multiply this to get this? No. So x1 and x2 are not, x and y are not independent. So you have to find the MGF of z. That's exactly what you're finding. So
yeah, in this MGF we have 1 minus 2t and 1 minus t means 2.
But they are not MGF. Are they tying out to MGF? I don't know. But are they tying out to MGF? They are not MGF, and the reason is that t is not less than 1. If t was less than 1, then it would be MGF. You understand? There are a lot of things over here. And it's product
if t is less than half, then t must be less than 1.
No, but what will happen if you put t is equal to 0.9? You cannot put that. You understand? So it's not a known MGF. I'm 100% sure you can understand that. So what to do? Now you have to calculate its partial fraction. I've done it correctly. Yes, so this is correct. So done it. Now you differentiate. It will be easier for you to differentiate now. Now you do mz of dash of 0. You get expectation of z, and you do mz of double dash of 0. You get expectation of z square. From there you get variance of z. All of you understood this, guys? All of you understood this?
Sir, I didn't get the part at start where means where you substituted T1 equal to T2 is equal to T. We need to find Z is equal to X plus 5. So, did you substitute according to the condition or is it a general type of substitution?
No, understand. We need to find out mgf of z, right? Z. Z is equal to x plus t. That means you need to find out what? You need to find out this expectation e to the power tz, right? This is what? This is.
Okay, sir, got it.
Yeah. All of you understood this, guys? You're right, Shantanu, in the live. Your idea is also correct. All of you understood this? Everyone understood? It's coming negative? Are you sure? Maybe I've done some calculation mistake over here. It's coming out to be negative. Sneha, can you just once again check once? Okay. But I have not done any mistake over here in calculation. Double derivative calculator online. So this is, can someone write, tell me, like it's 1 by 1 minus 2t into 1 minus t whole to the t. Differentiate 2 times, differentiate once. Yes, differentiate once, we are getting f dash of 0, we are getting that 1. We are getting 3. Expectation, we are getting 3. The first derivative is coming out to be this. That's the second derivative. Oh, I think this is not correct. There's an issue over here. It's like expectation this by 2 factorial is there. Sorry, there's a 2 factorial over here. So you can find out multiplied by 2 times. So you get double derivative, we get, so put 0, you get 1 again, niche, and upper you get 14. So expectation 14 you get. So you get expectation of z square is 28. And expectation of z whole square is 9. So you get variance is 19. Do you get variance 19, guys? Oh, because expectation of z square by 2 factorial is m double dash of, like, I think it's getting, no, wait, m double dash is doing, when you're doing that, no, I think, yeah, you're right, there is no multiplication of 2. So we are getting 14, so we are getting 5. So we are getting 5, guys. Good, fine. So it's non-negative. Good. Perfect. Okay, thank you guys, and let's leave it over here. And you can do this problem here, this problem at home. Follow me? Did you understand the solution?
Yes, yes.
So you can do this problem at home. Okay. How to do the expected value? It's very easy. You just find the marginal of a t, marginal of x, by putting t is equal to 0. So you get 2 by 3 into expectation of e to the power t 1. That is the marginal of mgf of t, expectation of, that's the mgf of x, and from that maybe you can find out some general, you find out the how it looks like. Any known quantity के साथ it looks like it 2 by 3 into the power t, some constant into the power t. Any known quantity के साथ it looks like known quantity के साथ it must look like is it right now? Oh, plus 1 by 3 heck. Yes. Okay, so now it looks like with Bernoulli 1 comma 1/3. So expected value of x1 is 1/3. Okay. All of you understood this, guys? All of you understood this one?
It would be the only 2 by 3, sorry.
2 by 3 होगा?
Q plus PET.
हाँ, thank you, yeah, you're right, 2 by 3 होगा. Yes, this is P actually. Yes, thank you. Perfect. Yeah, that's it. Okay, all of you understood it, guys? Any doubts? Clear? Everything clear? Perfect. Okay, so let's end the class over here, and I hope you enjoyed that. Perfect. And for the people who are in live, if you don't know about our crash courses, they're coming live from October, so do like share to your friends about the crash courses, and if you're in the already platinum course, it's free for you. Okay, so all the best, guys, and I will see you in the next video. Stay tuned and stay blessed. Bye bye. Don't forget to like, subscribe, and share to the students out there who really need this. Bye bye.